am Dr. Uma Priya, working as Assistant Professor in the Department of Chemical Engineering KPR IIT. Particularly today in this session we are going to discuss about chemical reaction engineering. So as a chemical engineer we all know very well about what is reaction and what are the types of reactions. Once again we are recalling these things. So first session we are going to discuss about what is reaction and what are the types of reactions we have. So reactions in this pattern, we will take the raw material as the reactant and we will provide a particular temperature, pressure and other conditions. Based upon the conditions we applied, the reactants it will combine with each other and it will give another material, not the same material, another material. We are calling that another material or end product as a product. So the same thing only here also I have mentioned. A chemical reaction is a process that leads to the transformation of one set of chemical substances to the another. So one set of chemical substances to the another, this process or transformation we are calling it as reaction. And the initial substance what we are taking, that one we are naming it as reactants, and the end material what we are receiving we are naming it as product. So those things only here also we have discussed, reactants and products, and we are giving the conditions, right? Those conditions are nothing but temperature, pressure and other environmental conditions. So based upon that one only the transformation it occurs. The next thing is types of reactions. We have so many types of reactions based upon some modes. So here I have listed out the modes of the classifications. First one is based upon the number of phases involved, we can classify the reactions. And the second one is the presence or absence of the catalyst also we can classify the reactions. And the third one is the nature of the overall reaction, we can classify the reactions. So we have so many types of reactions. So based upon these modes only, one is phases involved, the other one is catalyst presence or absence, the other one is nature of the overall reactions. Then based upon the phases involved, we can classify the reactions as first one homogeneous reaction, the second one is heterogeneous reaction. In the name itself, we can clearly explain what is homogeneous and what is heterogeneous. In the homogeneous, same kind of phases it occurs in this reaction, and in heterogeneous the different level of phases it occurs, or they are taking the raw material and product in the different phases. The same thing only here also I have mentioned. See, if all the reactants and products, even though reactants and products combinedly with catalysts, all the three materials are lying under the same phases, the single phases, that reaction is called as homogeneous. Here I have listed one example also. So C2H6 it is in the gaseous form, and the next one is C2H4 converting process, and C2H6 gaseous form, C2H4 also gaseous form, and the subproduct hydrogen also in the gaseous form. See, here this is reactant and these two things are products, and reactants and products, all the things are lying in the same phases, gaseous phases, so it is coming under the homogeneous reactions pattern. And the next one is heterogeneous reactions. So here we have discussed already, right? So reactants, products and catalysts. If the catalyst present is there, then catalyst. All the three things it should be in the same phases, that is homogeneous. Different phases means heterogeneous. Here see, if more than one phase is involved, if more than one phase is involved, that reaction is called as heterogeneous reaction. Here I have listed the examples also. See here this reactant it is in the gaseous form, and this product, one of the product it is in the solid form, the other product it is in the gaseous form. So here we have two phases, one is in solid, the other one is in gaseous. So this is heterogeneous. And the cold combustion process also, see, one is in solid, this carbon it is in the solid form, then oxygen gaseous form, then the product, it is in carbon dioxide, it is in gaseous form. So here also solid and gaseous are present. So it is lying under the heterogeneous reactions. So here homogeneous means same kind of phases. Heterogeneous means we have more than one phases involved in the reaction. These two things are based upon the phases we can classify the reactions. The next one is single and multiple reactions. In the name itself we can clearly mention single means one single reaction, it is enough to get the product from the raw material. Then in the multiple reactions we have so many steps of reactions. Either it may be in the series form, or it may be in the parallel form, or it may be in the series parallel combinedly also. So these things are coming under the multiple reactions to get the product from the raw material. See, single reactions and a single stoichiometric equation and single rate equations are chosen to represent the progress of the reaction. This is called as single reaction. Here I have mentioned one example also. This A is your raw material, B is your product. A gives B directly, even though B plus C occurs also, it is giving a single reaction pattern, right? So it is a single reaction. Okay, the next one is multiple reaction when more than one stoichiometric equation. We know what is stoichiometric equation. We have studied very well up in the chemistry subject. So this stoichiometric equation, more than one is applicable for giving one sort of converting raw material to product, means that is for the multiple reactions only. Here see, more than one stoichiometric equation is chosen to represent the observed changes. Observed changes, what they are meaning here means converting the raw material to product. Then more than one kinetic expressions is here. In later classes we will discuss about what is rate equation and what are the factors affecting the rate of reactions and those things. So these are coming under the kinetic expressions. Then if more than one kinetic expression is needed to follow the changing composition of all the reaction components, then it is said to be the multiple reaction. Then multiple reactions, again it can be divided into three more types. One is series reactions, then second one is parallel reactions, then third one is series parallel reactions. See, series reactions means this A gives B, the same time this B, it will not stop in that position. This B again it will be converted to C product. So this is like a series kind of thing, right? So we are naming this one as series reactions. So from A we are getting B. B as a product we can take it out, but if we allow that B to the process, again reactions, then this B it will convert into C. This is the series reactions. Then here see, A is the raw material. The parallel time, at the same time, A can give B product and this A raw material it can give C product also at the same time. Based upon the catalyst, based upon the temperatures, based upon the pressures, based upon the other conditions, we can convert this raw material A to the product B or C at the same time. So this is the example for the parallel reactions. And this is like combined series parallel reactions. Here we can see this A gives B is like series reactions. Then the same time it can give the product C also. And see here, A is raw material, B and C are product, right? Then from the product, C can react with A and it can give one more product as D. So parallelly these two reactions are happening. A gives B plus C and the A plus C gives D. This is indicating series reactions. And one more thing, this is indicating parallel reaction. And one more thing, see, A gives B. At the same time, it is giving C. And this C gives D. So it is denoting series reactions also. So only we are calling this particular reaction type as parallel and series reactions. So based upon this lengthy steps what we are mentioning or stoichiometric expression to show the reactions, we are naming the reaction as single and multiple reactions. First one is single step, so we are naming this one as single reactions. Then the second one is most of the things 2 reactions or 3 reactions are there. So we are naming this one as multiple reactions. Multiple reactions itself we have 3 more types. One is series reaction, parallel reaction. The other one is series parallel reaction. Series reaction means from one raw material we can get one intermediate material. From that material we can get one another material. A gives B gives C, and this parallel reaction, same raw material but different conditions, we can give 2 more products or 3 products. So this is coming under the parallel reactions. Then series parallel reactions, A gives B plus C. B plus C are product. From the product level it is taking the C, and this C gives again B as a product. This is like series reactions, and A gives B plus C parallelly. These reactions also can occur after particular time. So this is coming under the parallel reaction. And the next one is reversible and irreversible reactions. So like reversible, irreversible, in the name itself we can clearly explain. Reversible means one thing can happen, but after the particular time again it can be reversed. So this is nothing but your reversible reaction. See example, this is your raw material, and after the particular reaction the product is like this. Then if we maintain the same kind of circumstances, environmental conditions, this product again it can be converted into raw material. So these reactions are like carbon monoxide to carbon dioxide, then carbon dioxide to carbon monoxide. This cycle it will repeat. Again carbon cycle, sulfur cycle, oxygen cycle, nitrogen cycle, all the things are like this only. So in the same environmental condition, this product it has the capability of again coming back to as a raw material, like unstable condition. We are naming this one as unstable condition. So we can get the product, but this product is in the unstable condition. So this product it again can convert it into a raw material. This is the reversible reaction. And irreversible means here you can see into mark, right? So this into mark it denotes that this reversible reaction it never happens in this reaction. Like raw material, if it once converted as a product, this product is product only, definitely it will not get back into the raw material shape or raw material characteristics. So this is the irreversible reaction. To denote the irreversible and reversible reaction, we are using the symbol. For the reversible reaction, forward and backward reaction symbol we can use it. For the irreversible reaction, only the forward reaction symbol we can use it, or else we can use the backward reaction symbol. We can't use both the symbol at the same time. So this is the reversible and irreversible reactions. Then next one is catalytic and non-catalytic reaction. This catalytic and non-catalytic reactions, based upon the catalyst we are using, we are classifying the reaction as catalytic reactions and non-catalytic reactions. So before moving into the catalytic and non-catalytic reactions, we have to know about what is catalyst. So this catalyst, it is nothing but a substance. This substance, it will go and involve in the reaction, but it will not give any product characteristics changes, or it will not involve in the reaction at all, just it will speed up the reaction. So this is the advantage or application of the catalyst. Catalysts are defined as those substances which alter the rate of reaction. Rate of reaction is nothing but a simple term we can mention, the speed of the reaction. So it will involve or alter the rate of the reaction by changing the path of the reaction. So this is the application part of or use part of the catalyst. So if the reaction involves the catalyst into that, we are naming that one as catalytic reaction. If the reaction does not involve any catalyst substances in that reaction, we are naming that reaction as non-catalytic reactions. Then how the catalyst it alter the rate of the reaction means, see, this is uncatalytic reaction. This is catalytic reaction. We all know about the activation energy, right? Activation energy means what? At particular energy time, this reactant automatically it will convert into the product, right? So this external energy or internal energy built these things it will change if we give the catalyst into that reaction. If we give the catalyst into reaction, see, if without catalyst this activation energy level is this much peak. If we give the catalyst, this activation energy level it is less. That means within the particular less amount of energy itself, this reactant it can be converted into the product. So the time taken to reach this activation energy is high. The time taken to reach this level of activation energy is less. So this is the reason by using the catalyst in the reaction, the rate of reaction definitely it will get altered. That means we can increase the rate of reaction within the short duration with the help of the catalyst. So if we use the catalyst in the reaction, that is nothing but the catalytic reaction. If we are not using the catalyst in the reaction, that is nothing but the non-catalytic reaction. So here I have mentioned some of the examples for the catalytic reactions. See, carbon monoxide to butane reaction, we are using nickel as a catalyst. Here we can see two more reactions also for as an example. And this main character of the catalyst is, catalyst does not initiate a chemical reaction. It does not initiate a chemical reaction. It just alters the activation energy, so it speeds up the reactions. Then the catalyst it is not consumed in the reaction. If it gets consumed, then the product character itself it will get varied. We may not get the same kind of product what we expect. So the catalyst what we are choosing, it should not involve in the reaction. It should not initiate the reaction. So these things are main thing while choosing the catalyst. So this is the catalyst cycle. Here you can see very clearly, this is a part of the catalyst. Okay, this is the part of the catalyst, and this A is the one kind of raw material, and this raw material and this catalyst both are going to the reaction pattern, and we know very well about the catalyst. The catalyst it will not involve in the reaction, right? So this catalyst it just absorb the reactant. See here, it just absorbed, and one more reactant also they are providing in this particular part, that is reactant B. Again, this A it went and it just sticked in this part, and we are adding one more reactant B. This reactant B also it can go and occupy this place of the catalyst. Now A and B are just stick on the catalyst outer surface. Adsorption process it will occur. Then this A and B only it will reacted each other, and this catalyst just it will be seated as a catalyst only. Then see here, this catalyst even shape and character it doesn't change anywhere, right? Only the A and B combinedly reacted and converted as a product, one another different material, and this product also it will be on the surface area only. Then after the particular condition it will dissolve from the catalyst, and the product we can get it very easily. Catalyst it will be remain as a catalyst only for the entire process. Then we can use the catalyst for the next coming cycles also. So only we are choosing the catalyst very particularly. This catalyst it should not get involved in the reaction, and it should not initiate the reaction also. This is the cycle, catalyst cycle. We can use the repeated n number of cycle catalyst in the n number of cycle. Then after the particular time we can regenerate the catalyst also, and we can remove it once if the quality or character it comes down. Then next one is elementary reaction and non-elementary reaction. This elementary reaction, again this elementary reaction is nothing but a single step reaction, and non-elementary reaction is like multiple steps it will be there in to explain one single step itself. Example, it is the example for the elementary reaction. See, C2H5OH plus CH3COOH, it gives CH3COO C2H5 plus H2O. However, we want to split this reaction into the different part. No, we can't. Only one expression is enough to mention this reaction. But this is the example for the non-elementary reactions. Again, you can see the brief of non-element reactions in the next coming sessions. Now this is the example. H2 plus Br2 gives 2HBr. First H2, it will be like HH. Then Br, it will be like Br. Then H and Br, it will provide HBr. Then HBr plus Br. Now like that, so many intermediate reactions it will be happening here. So that's the reason we are naming this one as non-elementary reactions. Like we can see one single step reaction, but to get this product HBr, definitely this H2 and Br2, it will involve in the n number of reactions inside itself. So initiation, then intermediate process, then last one is propagation. So this kind of process it will be there in the non-elementary reaction. An elementary reaction is in chemistry is a type of chemical reaction that occurs in a single step with only one transition state. That means reactant converting into product. That is the one transition state involved in the conversion of the reactions to products. So this is the example for the elementary reaction, and here you can see reactants directly it reaches the activation energy converting into product. And in the non-elementary reactions, see this is the reactant. It reaches to the activation energy, but in middle of this again one intermediate occurred. This intermediate again it reaches to the activation energy, then only it is converting into the product level. See this reactant to the intermediate reactant, we can write one reaction. From the intermediate reactant to product, we can write one another reaction. But all together we are mentioning one single reaction only. But to get this product, it is taking two steps. That means intermediate reactant to intermediate one step, intermediate to product another step. Difference between the elementary and non-elementary reactions are, this is like a single step reaction. The transformation it occurs in the single step itself, but it is the multiple reaction non-elementary, and we can use like initial reactant and intermediate and product in that. We can see very clearly in this. So these things only here also I have listed out. For elementary reactions, the order of each reactant in the rate of reaction is identical. Only one step is enough to explain what is rate of reactions, what is rate constant. But these things, because this stoichiometric equation is single only for this elementary reaction. But for the non-elementary reactions, the rate equations and the rate constant, everything is like n number. Based upon the reactions, however we are giving to explain the single step of the reaction, like that kind of level, we can get the rate equation also and we can get the rate constant also. The non-elementary reactions, the order of each reactant in the rate equation is not identical. So only they are mentioning this one as not identical with the stoichiometric coefficient of the species in the stoichiometric equation. And single step reaction, this is multiple step reaction, and this elementary reactions are very simple. This non-elementary reactions are complex in nature because not a single step reactions, right? 2 or 3 more steps are there. So complex reactions these things are. And these things we can mention it as single integer, but this one will not, we can't get single integer, we'll get the like decimal points also. So with this we are concluding what is reaction and what are the types of reactions, and you all came across what is reactions and what are all the types of reactions. Again, if you want, you can again visit this particular presentation, and if you get any query, you can contact me. And in the next session, we will discuss about what is rate of reactions, rate constants, and what is reaction kinetics.